From South Bend, Indiana, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
So I think the best case was we made a bolt rolling die, essentially, that was 3D printed. We could 3D print it, we could surface enhance it, and ship it to them with no machining, nothing after that sense. And I think it even outperformed a lot of their old dies and got some better tool life out of it. So those type of use cases was what we searched for, but it always took quite a long time in order to get to that final state. So
that's Faith Oehlerking. She works in manufacturing programs for Beehive Industries. Her experience has been working in the aviation and additive manufacturing industry with a focus on laser powder bed fusion. She has a Bachelor of Science degree focused in Metallurgical and Materials Engineering from Colorado School of Mines. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcasts, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your team are looking for materials, qualification, or general additive manufacturing support, reach out to us through our website or via email at info@3degreescompany.com. All right, Faith, thank you so much for joining the show today. Excited for the conversation. I like to start kind of all these episodes off like very kind of early days. So what were some of the, like, where were you born? What kind of got you on the path towards additive manufacturing?
Sure. Yeah. So thanks, Mike, for having me. I grew up in the Chicago area, born to two engineers. So kind of definitely in my blood, and was probably, the most support I got was in the kind of the STEM sciences at home. And so engineering was kind of always my path. I think majority of my family, 90%, went to University of Illinois for engineering, and it was just kind of written in stone. But I will say I was the one black sheep that did not go to University of Illinois and went to Colorado School of Mines instead. And that's mainly because fell in love with the mountains, fell in love with outdoor activities, and the fact that they had a very world-renowned metallurgical and materials engineering degree. When I was younger, I didn't even know that was a thing, but understanding, once I was in high school, understanding that it was a mixture of chemistry and physics, and the fact that you could actually physically see the product of, what you're changing at the microscopic level. Material science was like a huge passion of mine towards the end of school, and I was looking for, colleges that had that. So Colorado School of Mines it was.
Were your parents metallurgists or kind of mechanical engineers?
No, yeah. My dad was a mechanical engineer. My mom was an industrial engineer. So material science, my dad was aware of, but, it was always kind of the side thing that he had to deal with more so than what he was passionate about. But, for me, I think the chemistry aspect of it is what kind of got me in at first. And I think the fact that, changing something that might not be useful into something that could be useful, for sustainability reasons, was really what kind of got me in there at first.
Do you remember them helping you on what was it about? Was it being around them all the time, hearing them talk about it? What in those, when you were younger in high school, middle school, were there a memory that stuck out in terms of kind of that motivation?
Definitely. I think one of my core memories was, young, 8, 9, 10. And the way that my dad wanted to bond was doing a science experiment. And he loves his coffee, and he has about maybe 20 different types of coffee cups in our cupboard. And he's like, you know what? It's Saturday. It's rainy. Let's have fun and decide which of my coffee cups can hold heat the longest and graph it out, essentially. And so we would do little things like that, just little experiments around the home. I know we talked about bikes a lot. He worked on cars quite often, so I'd be there in the garage with him. But anything finding out the temperature of his coffee cups, or science homework, he would help me out and sit me down. Whereas anything writing, anything more on the creative side was kind of left to my own devices. So, but that coffee cup one, I think he still has the one that held heat the longest. It's still in that cupboard right now. So there's definitely some good results to that one.
And so when you went to mines, did you know that you wanted to do materials engineering, or was it metals? Like what, that's kind of a niche. I mean, I'm a materials engineer, but I didn't really know about it in high school. But like, where did you kind of find that interest? And
yeah, so University of Illinois actually has this great program. It's called the Engineering Open House. And at the time, I had a cousin there. And it's basically just a big science fair with a lot of booths and whatnot, where each engineering discipline had like little science fair booths of things you could touch, things you could see, all the experiments that they ran. And I walked around and saw all of each, but the material science ones I thought was the coolest. It was like they had the gloop, the one that I forget what it's actually called, but it's like the cornstarch with glue that, becomes hard once you put pressure on it, but it's kind of viscous when it's in other states. There was one board where it's like they turned corn husk waste and they turned it into particle board and things of that nature. So just for me, it was the most like visually like engaging type of discipline for me. And everyone seemed to be having a good time. I don't know. The vibes are good. So
us materials engineers are cool cats, right?
Yeah, exactly. So I did declare like materials engineering as a discipline going into like as a freshman, and I think I'm pretty lucky in the sense that I still love it to this day, and I still use it. And I think I was one of few who actually knew what I wanted going to school for that major, and still use it every day.
And did you have to? I mean, material science is pretty broad. Did you know you wanted to do metallurgy, or were you interested in biomaterials or biomedical, whatever kind of sub-discipline that you could do?
Yeah, I think going into college, I didn't have like any specific material that I was interested. I don't think metals was taught, to be honest with you. I think it was more so on the ceramic side of things, or maybe like more of the organic type of materials. And then even in school, we focused mainly on steel. And I got kind of steel overload, I would say, in college, because I mean, that's just, the most foundations of a lot of metallurgy is from that steel, and a lot of where Colorado School of Mines funding is coming from. So lots of steel. I actually thought in college that ceramics was the way to go, but had kind of a little bit of a focus in that sense. But after school and through internships, metals was kind of the most accessible and the most I knew about, and like kind of had the biggest foundation from Colorado School of Mines. And that's what led me into metal additive manufacturing. And I don't regret that one bit.
Do you remember the first time you saw a 3D printer?
It wasn't until after college. I mean, honestly, Colorado School of Mines is doing a great job with having printers on site and having a very focused additive manufacturing kind of group. But at the time when I was there, that wasn't a thing just yet. I didn't even know that metal additive manufacturing was even a thing until I found a startup out on the East Coast that just needed metallurgy experience. They would teach me the 3D printing as long as I knew some basics on metallurgy and was willing to get my hands dirty. They'll teach me the 3D printing side of things. So we had a plastic printer at school. We were toying around with some ceramic printing as well, but no metal additive machines were on campus. So first time seeing a metal additive machine was on the job.
And what was that for? Was that your first job, the East Coast kind of stint, or was that kind of in the middle of?
Yeah, I had some internships in the investment casting industry. So Alcoa Helmet, now just Helmet Aerospace. So that I had internships there during school, and then right after college, a quick internship at SpaceX, but also in the investment casting type of realm. But then right after that summer, was looking for jobs and found a startup called NanoSteel, which switched to Formetrics, and were a metal additive 3D printing startup.
And how did you go about your job search kind of back then? Were you like geography focused? Were you what you were doing focused? Small company, big company?
Yeah, at that time, geography didn't matter to me at all. I was just really looking for something engaging, something that, was kind of newer on the technology side. I didn't know that I liked small companies at that time, but I guess that was kind of the energy I was looking for. Just a fast-paced environment where I could use my degree. And so my job search was kind of ad hoc using LinkedIn, Indeed, things like that. But what really got me that first full-time job was through a connection of my professors. So I reached out to them saying like, hey, I'm looking. If anyone reaches out to you, just let me know if you hear of anything on the grapevine. And pretty soon after that, my manager at the time emailed one of the professors looking for metallurgy students that are looking for a job. So it really pays off to have those connections through school and then even afterwards, because you never know what might pop up.
And what was that first job like? What were the sorts of things you were doing as a new materials engineer in the industry?
Yeah, so NanoSteel, we designed a tool steel specifically for additive manufacturing. And so tool steels notoriously can crack pretty easily if you're going towards like the really high carbon content. But we had a secret sauce of chemistries that we made into metal powder and was meant for metal additive manufacturing. I think the startup, I moved out to Providence, Rhode Island, and that startup at the time was maybe max 15 people. We spun out the additive manufacturing side of NanoSteel, which had some other business as well, and became Formetrics, where we were a team of about 5 to 8. So I can't really put my job into one sentence, because with that little people, you're literally doing everything. But I would say my main role is that we got a add-up, form-up 350 printer on site. And my main job was to program our experiments. We did a lot of design of experiments for our own material that we were designing, maintaining the printer, setting up the printer, and then all of the kind of lab work, metallography and analysis afterwards. I mean, we shared that between the group there, but that was kind of the main thing, was running a lot of experiments on the material we designed and seeing like what limits were and what the limits were on mechanical properties, chemical properties, everything, just trying to discover what this new material could do, which was pretty cool.
And then the idea with the companies, you'd sell that material you'd be a material supplier essentially.
Exactly.
And kind of go out and find applications or people that might be using, that might want to use it.
Yeah, exactly. So that would mean either selling to printer OEMs, that could be selling to actual end application users like tool and die manufacturers. Like our customers kind of had a big range.
And what was kind of the approach there in your mind with that? Are you looking for people that are familiar with 3D printing and want to kind of expand their material set? Or is it more like, hey, let's look at people using this in conventional manufacturing, see if we can kind of find parts or find use cases? Was it heavily weighted one way or the other?
I think a lot of our most successful customers were actually like kind of the tool and die users or manufacturers. A lot of them had supply chain issues where they were having people like mom and pop shops make their tools and dies, and they didn't want to be constrained to one single source. So 3D printing kind of opened up a lot of flexibility on that sense. But at the time, the additive manufacturing materials just couldn't get the hardness or the properties that a lot of like D2, H13 traditionally manufactured tool steels could get to. So I think the best case was we made a bolt rolling die, essentially, that was 3D printed. We could 3D print it, we could surface enhance it and ship it to them with no machining, nothing after that sense. And I think it even outperformed a lot of their old dies and got some better tool life out of it. So those type of use cases was what we searched for, but it always took quite a long time in order to get to that final state. So kind of tried to diversify a lot of our customer profile. But the cool case of that is that customer, McLean Fog, is actually the one that bought that technology, our powder. And so now Formetrics is considered McLean Fog Solutions, and they're a tool and die manufacturer.
Awesome. And so what was the next step on your career path?
Yeah, so next up was still on material development. I moved to HC Starch Solutions. They are a refractory metal manufacturer, both in the traditional sense, a lot of forging and forming type of ways that they made their refractory metals, but they just started up in investigating and researching into additive manufacturing for refractory metals. And so they needed someone kind of to run the machine, run the experiments, very similar to what I was doing at Formetrics and NanoSteel, but just with a new material. So molybdenum, tantalum, tungsten, and niobium type materials, and running that there in their Coldwater, Michigan site. So
and what for those who aren't materials engineers listening, like, do you want to just explain what you mean with refractory, or what's different from those than some other metals that you might work with?
Yeah, so refractory metals are some of the highest temperature materials out there, and probably some of the heaviest as well. So they're used in very high-end applications where temperature is very, very high. So like molybdenum is actually used in like furnace components, and in like hypersonics as well, and that's just due to their heat resistance that they give off. But because of how their chemistry and like how heat resistant they are, it is traditionally pretty difficult to manufacture them and get them into the shape that you want. So on the traditional side, it would be pretty long and a lot of steps in order to get a final form of what you want. Whereas with 3D printing, hopefully the goal was you get near net shape pretty quickly. But it's not a common material for 3D printing as of yet. There's a lot of still research going on with it, but the most popular material right now is niobium C103, and that's gained a lot of traction in the space type of industry due to that kind of high temp capabilities that it has.
And are there any, we can get, that's more a materials question, but we can get into that later. But so in this role as well, you're also interfacing kind of in that same challenging area where you're kind of developing the material, developing the specs, but then also trying to sell it and find those use cases. So how challenging is that in the additive space? That's a lot of companies are in that stage across probably every sector, is right, trying to find what's the right use case, right? What's the right way that we can leverage the technology. So what did you take from your time at NanoSteel Formetrics that kind of was applied to HC Starch?
I think a lot of it was just making sure you knew the mechanical properties before selling it, right? I mean, it's always the first questions that you get is like, well, how repeatable is this? What the properties that you're getting, and what is the limit? So before we would even go to market, there's a lot of testing, a lot of getting statistical type of confidence in the numbers that you're getting, and then creating a full package. So a lot of times you have like material data sheets or mechanical data sheets that have a lot of experiments behind it before you go anything to market. I think you also have to target the type of customers you have and have them be open-minded to not only a new material, which is, I know for some legacy companies could be difficult, but also a new technology. So often like combining those two and to find a certain person willing to have both of those be new to them was definitely difficult. But those companies that were really future thinking, forward thinking, those were the ones we really tried to focus on. And I think that's, yeah, go ahead.
And it's probably a practical thing as well. Like, right, when you buy a 290 or a SLM system, right, they're going to give you something that works. It's a titanium or aluminum silicon mag or something. And getting someone to put in a new material is not always the easiest thing to convince them of.
Yeah, and when you buy that material from EOS, they give you the parameter set. So all you really have to focus on is the geometry and the support structure. And so once we had like a set up customer base, that's what they expected. So we also would provide them a parameter set guideline. It's like, this is at least your foundation for your bulk parameters, or to at least get the properties that you want, and you can adjust from here. But we always had to provide, starting settings for your printer in order to sell the material, the powder.
And over the time that you were there, and even kind of going back to NanoSteel, how did you feel that the industry was evolving? Like the customer engagements that you were talking to, was like the learning curve, like were people getting smarter over that time and asking different questions? Or how how matured do you think the industry is, maybe even today too? Like, do you still see a lot of those same struggles or kind of challenges?
I still see a lot of that struggle because I think immediately people wanted to industrialize additive manufacturing, and at that time, like, it's still, the printers weren't necessarily 100% reliable. The parameters we got were super basic, so we really needed a customer that was knowledgeable in additive manufacturing that could kind of take it over from once we sell them the powder and printing, which means like their own R&D team, their own type of researcher or material science person that can do more experiments. I think we're still running. I think it's gotten better since when I first started. I think boutique materials in the additive manufacturing type of realm has been accepted a lot more. But at the beginning, everyone was just asking for traditional materials being pushed into additive manufacturing, and that's just inherent to the process. That can't be the case every single time. So we always had to answer questions of, how does this compare to wrought bar or the traditional manufacturing, and do like a side-by-side comparison. But the reality is, it's just totally different process, totally different properties, and you should just accept the new, which I think has gotten better since that time.
Nice. And do you want to describe kind of your role in terms of like designing some of these experiments? Like what sorts of things are you testing? What is important at a broad level for someone that may never have seen some of these technology? Well, most people are, at least listening to this, are somewhat familiar with the metal laser based systems, but what are the things that, like the dials that you're turning, or the things that are important that you're working on? Yeah.
So when you're working with a brand new material, you really have to start at the basics of, can I even get a dense part that can print a cube, literally just a centimeter by centimeter by centimeter cube to completion without failing. And the way you do that is, there's four main things that you can change on the laser, which is your laser power, your laser spacing, the laser speed, as well as the layer thickness that you're printing at. And the amount of, I think it's infinity how many different ways that you can adjust those. But basically, you start really broad, and then you kind of hone in experiment after experiment to try to get those optimal settings. The amount of cubes I've printed and then cut up and like looked under a microscope has been quite a lot in my time period. But once you have that cube, you normally cut it up, look at it under a microscope, and measure the amount of porosity that you're getting to see how dense your material is. The shape of that porosity can kind of tell you where you need to go. If you have too low of energy, the pores will look a certain way, pretty jagged. We call that lack of fusion. If you have too high of energy, it'll be gas inclusion, so you have a little bit of vaporization in your material. So using that kind of microscopic knowledge, you can kind of hone in your parameter set from there. Working with refractory metals, there's a lot of other things that you need to consider. One is like your oxygen content, especially within your printer, as well as like heating your build plate. There's many other kind of levers you can pull, but at least for the beginners and basics, like your laser settings is your number one place to start.
Awesome. And you want to talk about kind of now where you are, what you're working on?
Yeah. So after a few years in that material development space, I think, I printed a lot of cubes. I printed a lot of tensile bars in my time, and I got involved in the additive industry a lot more. And I got to see so many cool applications and cool designs that additive manufacturing could provide. And I'm like, okay, I have the foundations of how printers work, what settings you need to do, but I really want to go towards the design, the application side of things, and working with, once you have that material set up, what use case could these parts be used for? So that kind of led me to my role at Beehive Industries, which was very new at the time, and as a role as an applications engineer. So kind of externally facing, working with our customers to see like what parts they need to print and, what the best way to print them and get to their design that they needed. And at that time, we really focused on aerospace and defense, but we had, inquiries from all over, all different industries. And so it was really great to see all the different types of use cases that Additive could provide, and just at least talking to the customer and seeing what their needs were and seeing how we could help them and see how 3D printing could fit.
And so you guys have a bunch of machine capabilities and are going out to find or support customer projects. Is that the idea?
Yeah. Okay. So Beehive, we have a service bureau side of our business. So we have a lot of metal machines of different sizes and build volumes. That was kind of the applications engineering that I worked on. We also have kind of a plastics business as well, where we sell to casting foundries. But really, we have a lot of printers, a lot of different materials, and quoting projects using the capabilities we had in-house.
Awesome. And are there, you can answer this as broadly as you want, but are there industries that have been more forwardly adopting additive than others?
Yeah, I think just right now we're still seeing quite a lot of, defense and aerospace. I think we're the top two that we're seeing, and quite a big ramp up in the defense industry within the past couple of years or so. And I think a lot of that is just due to the overall government being interested in additive manufacturing, a lot more funding kind of happening in that space. And Beehive acquired Volunteer Aerospace out in Knoxville, Tennessee, and that was their kind of bread and butter. So, and had a lot of historical customers kind of in that space. So we've adopted that since. I think for us as Beehive, we've also kind of created our own product as well. And so I started out as an application engineer, and now I'm manufacturing programs leader for our propulsion systems group. And this whole group is, we are designing our own engine products for the defense industry, where we actually own the design, we own the printing, and we're owning the testing and everything for the defense industry. So really, the past couple of years, everything's been aerospace and defense for me.
And talk about that transition. I mean, you go from the R&D, new material, new settings, new hey, we just want to print a cube to now you've got to get something into a shape, repeatable. You have to have all the supply chain, all that kind of quality in there. Like from a material standpoint, how does anything that you're doing change in terms of the types of experiments, type of benchmarking, type of just quality measurements you go through as you mature kind of from a material R&D stage to, hey, this is a finished part?
Yeah. I think right now with the parts that we're making and how critical they all fit together and whatnot, what I've learned is you really want the printing to be reliable. I'm almost back to basics on materials, on Inconel 718, Inconel 625, tried and true metal additive materials in order to get the products we want and industrialize them. So I think for now, for me, I've moved from, I know the foundations, but now my scope is so much broader, from not just printing. It's from printing to heat treatment to post-processing and then machining and inspection. So I think I didn't do this on purpose, but I just didn't each step of my career has kind of been a building block to additive manufacturing fitting into a whole supply chain. And it's only being a small step in that whole supply chain in there.
That's super exciting.
It's been really cool. Yeah.
One other thing, I'm always curious, in you're very materials focused, but do you want to talk about some of the other job roles in this kind of ecosystem that you would see in making an actual product? What are some of there's workflow steps and how the material goes from a powder to a finished part, but maybe talk a little bit about other, the people part of that as well.
Yeah. So at least for us, for our internal products group, which is great because we can kind of own a lot of it. We have design engineers that are literally just, focused on the overall performance and efficiency of our product. And they have a lot of aerospace and defense type of background, and maybe not necessarily the additive. And they come up with the design, and they work with additive manufacturing specific engineers to make sure that the design that they have can be printed in one of our printers. And that type of communication is really, really critical for, the success of a lot of our products. Our additive engineers take it over from there. They take those designs, they add support structures to them where needed. They kind of consider everything downstream to make sure that additive is successful for machining, it's successful for post-processing technologies, things like that. And then once it's printed and heat treated, it moves towards a manufacturing engineer who will handle kind of surface enhancement type of technologies. So trying to get the surface roughness down to help our airflow, for example, and that can be done through multiple ways. And then from there, it goes from machining. We have a machining team here at Beehive, which is on site, and then total inspection. So each of those steps has an engineer kind of holding it. We have operators, we have technicians working those machines. And then overall, there's a program manager or a project engineer that's kind of making sure that everything's on schedule and it's within cost and within budget. And it's also just making sure that people are talking to each other too, which I think can sometimes be the hardest part because there's so many different people that touch this part, and you want to make sure that everyone has their feedback in there.
Awesome. So just a couple more questions. First, We're getting towards the end of 2023. What are you excited about for 2024?
2024. Yeah, I think it's been really cool to see the new types of printer technologies that are out there. I think there's been a lot of growth within this past year and it's only growing. But I think relevant to me and my job is more so like the post-processing type of technologies and how we fit additive into, a machine shop and how to connect those two types of things and combining those type of technologies or hybrid technologies as well. I think those are the biggest things that I'm looking forward to. And I'm always looking for the newest type of surface enhancement technology out there that works with additive. So always keeping an eye on that.
Awesome. So last question, more of a fun one. What's a book or that has made a impact on your career or kind of your mindset?
Oh, that's a good question. There is a joke here at the office because one of my old managers gave me a huge textbook. It's the Metals Handbook. It's literally about like 10, 15 pounds. It's basically how I reserve my desk. It's how, I claim my space. And whenever someone comes to me for a materials question, I kind of like try to find this in here. And if you can't, come back to me. So I think that Metals Handbook, is useful in so many ways. It's a huge textbook. No one's going to read through it all, but the amount of times it's come handy for me to like look at new materials that I don't have much background on has been super helpful.
Awesome. Well, Faith, thanks so much for joining the show today. Awesome to hear your story and all the work that you're doing. So I look forward to seeing you around the industry.
Yeah, thanks, Mike. This was fun.